Let's take another example that combines a radical and linear functions. Let's have f of x equal the square root of x, and our g of x equal 4x plus 9. Evaluate f of g and g of f. Let's start with the first one. F of g is equal f of g of x. So we are going to substitute g of x in f, and our f is root x. So instead of having x now, it's going to be g of x, you remember, which will give us the square root of our g of x is 4x plus 9. This becomes our final answer. Let's solve for g of f. G of f is equal g of f of x. We are going to be substituting f of x in g, and our g is 4. Instead of having x there, we replace it with f of x, which is root x plus 9. And this becomes our final answer. Let's take another example, which is an exponential function. Evaluating the composite of exponential function and a linear function. So, sorry, not a linear. Let's take a quadratic function or a polynomial. Let us have that our f of x is equal the exponential function, and g of x is 3x squared. Let's take 3x squared plus 2. Let's evaluate f of g. So f of g will give us f of g, which is equal f of g of x, and our f of x is e to the power of x, so we'll replace the x with g of x. So this will give us g of x, which is equal e to the power of 3x plus 2. This becomes the final answer. Let's take another example. Let's solve for the same exponential and polynomial. Let's solve for g of f, which will give us g of f of x, which is equal, our g is 3. Now we are going to have f of x squared plus 2. So we are going to have 3, and our f of x will give us the exponential square plus 2. And the final answer, this will give us 3 multiply. If we open, expand this, is going to be e 2x plus 2. This becomes the final answer. Let's take one more example that combines a trigonometry and an exponential function. Let's take all of this out. Let's take one more example for polynomials. Sorry, not polynomial. Let's take one example that combines a trig function and exponential function. If we have that our f of x is the exponential function and our g of x is equal cos x, and we are asked to evaluate f of g. Now, how do we solve this? F of g is equal f of g of x, and our f is the exponential function e to the power of x, and we'll replace that with g of x, which is cos x, and that becomes our final answer. Let's take a reciprocal and logarithm function. For instance, another example, if we have that our f of x is given to be ln x, and our g of x, it's equal 1 all over x plus 2. Now evaluate f of g. Please, you can pause the video and try this out. When you resume, we solve it together. So our f of x f of g is f of g of x, and which will give us our f is ln x. So instead of having x, we are going to have g of x, so that it would give us ln 1 all over x plus 2. And that will imply that our ln x, we can take this to the top, right? We make this a linear function, which is possible. So we can have ln, we have x plus 2 raised to the power of minus 1. This is the same as what we have here. And we can break it further from here. And this will give us equivalent to minus ln x plus 2, which is the final answer. One more example before we uh, bring composite function to a stop. Let's take an example that combines a trig function and a radical. All right, a function with a root. Let's say that our f of x, another example, let's have our f of x to equal the square root of x like we had before, and our g of x to equal 1 minus sine x. Now, evaluating f of g. Let's evaluate f of g, which will give us f of g of x. Alright, and this will be equal. Now our f is the square root of x. So instead of having x, we are going to have 1 minus sine x, which is g of x. And I think this is our final answer here. We can't break it down further.